Welcome, everybody. Don't look now, but it is now the last session on Thursday at reInvent, so congratulations to us all for making it through another week, and thank you so much for spending your very last session here with Craig and I today. We're going to be talking about how Intercontinental Exchange implemented a developer-focused DevSecOps practice, and we're really going to be focusing on some of the cultural sort of foundations of DevSecOps, especially as we're now sort of at the maybe 10-year mark after the origination of the term, and frankly, it's been a long hype cycle. So I think we're going to have a lot of interesting stuff to get into here. My name is Clinton Herget. I am the Field CTO at Snyk, who's sponsoring this session. Snyk is a developer-focused application security platform. It's pronounced like a pair of sneakers or sneaking around. It's also an acronym, stands for So Now You Know. Now, hopefully at the end of this hour, we'll all know a little bit more about mature DevSecOps practice. I'm thrilled to be joined today by Craig Lambert, who's the Senior Director of Application Security and Red Team at Intercontinental Exchange. Craig, do you want to tell everybody a little bit more about ICE and what you do on the security team?
Yeah, sure. Thanks, Clinton. And I'm glad someone asked our moms for our childhood photos.
Aren't we so cute in our teenage years here?
Let's get those updated. But yeah, thank you. I'm Craig Lambert. I've been at ICE for almost a decade now. So for those of you that don't know who ICE is and what ICE does, probably more familiar with the New York Stock Exchange. We bought the NYSE back in 2011, the Equities Exchange. But we're involved in, before then, we really got our start in the derivatives trading, exchanges and clearing business. And some of our other businesses are fixed income data services and mortgage. Well, what does that all mean? What's our mission? Really, it's to provide access and transparency to markets and to make them more efficient. That's really the stated goal. So in real terms, that means the trading floor no longer really works on paper and people on the phones. It's all digital transactions. In the mortgage space, really we want to reinvent that so you're not having to go to the bank with a box of paperwork. We want to seamlessly connect the end-to-end. So it's all about really digitizing what once were analog processes. So to that end, what do I do at ICE? I have global responsibility for application security, which is 1,600 applications supporting 4,000 developers.
Well, fantastic. My bio is actually quite a bit easier. I spent about 20-odd years building software for a living, managing developers. And now I talk about building software for a living, which is quite a bit easier. So would highly recommend that as a career transition to any overworked developers in the room. So what I think we're going to do today is, first of all, start talking about what is it that makes modern software development different? Why was there a need for DevSecOps in the first place? How has the security landscape, in particular the AppSec landscape, changed in response to DevOps? And where are there still potentially some gaps that might need to be filled in? And then, Craig, I'm going to turn it over to you and talk a little bit more about some of the cultural trends in DevSecOps practice that you've seen over the course of your career, in particular your time at ICE. What is that kind of developer experience looking like today? And then let's talk maybe about what's next. What do we see on the kind of the horizon for the evolution of DevSecOps practice? So just to kind of dig in here, apologies, the slide formatting is a little bit drunk. It's still hanging over from last night. When we think about traditional software development, right, we think about these very long development cycles that are measured in months often, everybody working together kind of in the same stage of a waterfall-based process, siloed development and operations teams, very rigid requirements definitions, again, in this very waterfall, define the requirements first in very intricate detail and then go into application design, very large teams, very monolithic applications, often deployed physically onto infrastructure that was often in the same building as the people building the software, and very limited supply chains as a result. You had developers, they were writing code Most of it was first party, and there was not a lot of sense of a large software supply chain. Now, obviously, all of that has changed, right? We deploy every few minutes, if not every few seconds. We have integrated platform or DevOps teams that kind of manage the experience of the developer in most large organizations. We work in these very rapid, agile, iterative cycles that are short. Our teams are much smaller. We have microservices instead of monoliths. And the software supply chain looks vastly different today. We have very complex, opaque, cloud-native applications. We have APIs we call out to. We have open source dependencies. We have containers. So the job of a developer is very different, and a piece of software fundamentally looks different today than it used to in the past. What that means is security has to catch up, right? So DevOps happened, and it was realized that, well, as you're devolving responsibility onto these frontline developer teams to allow them to move faster, one of the corresponding limitations is you have less visibility into what those teams are doing. So, the traditional story is security vendors came along and they said, well, we'll just stick the sec in between the dev and the ops, right? And everything will work out. Well, unfortunately, that wasn't quite what happened, right? Because the traditional application security approach, when applied to DevOps-style velocity, fundamentally doesn't quite work out, right? We're still testing after development as opposed to testing continuously as a part of a continuous integration or deployment workflow. We were still doing audit-based security using tools that were designed to generate a big PDF or a list of everything that was wrong, as opposed to a fix-based security that enabled developers to understand not only the vulnerability they were introducing, but also the remediation. We were still securing code and infrastructure separately with different kinds of tools rather than looking at that holistic risk context. And we were still relying on a very small security team for a large developer population, as opposed to integrating security champions within developer teams. So I guess I'll kind of turn it over to you, Craig. Is this a valid sense of how you've seen the DevSecOps world evolve? And I note that the term was coined now over 10 years ago, right? We're sitting now in 2024, still talking about how we arrive at mature DevSecOps and how we shift left into the developer workflow. What happened?
Yeah, so for some context, I think our perspective and how the application development is sort of evolved in terms of our applications specifically. And bear in mind, slightly over 10 years ago, we bought the NYSE, and along with that was an entire data center. And a lot of our bread and butter is actually around that data center, something called the ICE Cloud or ICE Global Network. It's effectively both internal infrastructure as well as a customer supporting network for trading. And so we have this. So what do you do with it? Well, you keep it, of course, and you work with what you have. But ultimately, we recognize the need for cloud-based architectures, and we did a lot of work probably about 10 years ago to move some core applications for the stock exchange to AWS, and then separately. So as a company, early on we grew organically. It's a kind of standard story. You get larger, it's harder to make those kind of gains. We, especially as we were getting into the mortgage business, we purchased a product. We purchased a company called Ellie Mae. The main product is a product called Encompass. It's a loan origination software. It originates about half of the mortgages in the US today, and that's entirely AWS. So we're really in the game at that point, like it or not, right? So it's almost a tale of two worlds because we've been so used to this three-tiered architecture. We've done a good chunk, but not really forced to do it, and then more recently, like really getting our arms around this complex application. So for us, it's like, well, how do you manage that? And really it comes down to we have a assured security language, especially when it comes to remediations. And maybe I'll go back to how we think about applications in particular. We tier applications based on priority. There's a number of criteria, but ultimately, in simple terms, it's exposure, contextual awareness. Like if the app's on the internet, you focus on those things first,
Right.
and kind of then purr things back in terms of what you do from a testing and controls. I mean, keep the controls, but defense in depth and all that good stuff. But so we had tiering process, which is everyone's aware of that process, and we also have this ticketing system that is universally applied across the company. There's top-down governance around that, and it's effectively taking all the vulnerabilities from different sources, contextualizing those depending on criteria. So, like Snyk, an example is Snyk, reachability for SCA. So if a function cannot actually be called, then is it really a critical? So we take that information and normalize it, so we have a common language, lingua franca, across our discussion.
Yeah. Well, so you said a couple interesting things there. You used the word context a couple of times, which I think is really interesting, right? Because from the perspective of a developer, as I'm making decisions about what goes into my applications, I often can't see the security implications or the risk that I'm introducing until it's too late. So there's almost this event horizon kind of problem, right? I have the responsibility, because we've shifted left, quote unquote. What we've really done is we've shifted the responsibility for security into the developer workflow. So we now block builds before they get into production, right? We have IDE plugins that developers can use to be scanning their code, scanning their dependencies. But what they lack is the proper understanding of that risk context. And you just mentioned a few really key pieces of it that come from the now large, opaque, complex cloud-native software supply chains, right? So reachability is an important one. The understanding that just because you might have a vulnerability sitting in an open source dependency or sitting on a container doesn't actually make that a risk, because it may not be reachable. There may not be a way in from the outside for an attacker to even access that vulnerable piece of code. So now that doesn't mean you don't fix it necessarily, but it does mean that you want to think differently about the prioritization versus just looking at the severity, right? CVSS is a great scoring mechanism in theory, because it is saying in an idealized world, this is how you should think about the risk. But obviously it can't know the context of your environment.
Yep.
You also mentioned the business criticality of the asset, right? Which a developer might not necessarily understand in their workflow, particularly when we're working in this now very microservice and container-oriented world, in which I might be working on a piece of middleware, but I don't understand which teams then inherit that middleware and build on top of it that then might become a mission-critical application. So there's all of this context that is missing from the developer experience, but what we've shifted left is the responsibility without the context. So I often think of that as throwing left versus shifting left. It makes the developer's job even harder now, because they're expected to have this impact on security because they want to be doing mature DevSecOps, but they don't actually have access to any of that information or context that is further on the right of the SDLC to help them understand the risk that they're introducing. Is that something you've seen as well?
Yeah. There's a total disconnect, in terms of implementation and trying to get. I can't go to my developers and just give them the vulnerabilities as they stand without any contextual information, because there's just so many. And it is really impossible to fix everything in spite of what you'll hear. I think it's a little bit disingenuous, but you hear people who may not be in the business of fixing things. Maybe they're a consultant or tell you should fix everything, fix your bugs, It's like, well, there's just so many, right? So I don't want to give all those things and just burn people out, lose all kind of credibility for things that aren't exploitable. So that's where our process really kind of helps with that. And we have credibility on that basis. We spend a lot of time thinking things through. When we use a new, say, product that will generate vulnerabilities, so a vulnerability source that flows into our IPT process, we take a long time before those go production goes live. So we know exactly how many are going to hit those teams, what the workload is going to be like, whether we need to make any tweaks to the context in terms of exploitability, and things like application criticality weighs on that too.
Right.
So it's buried deep in our data center, and you need firewall rules to get to it. Or is it on the internet and you have sensitive data in the application?
And it's often difficult or impossible for a developer to tell in their workflow which of those two cases or anything in between is true. There might be compensating controls on the edge that I'm unaware of as a developer that would indicate to me that I should probably prioritize that remediation differently, but often that doesn't reach me at the right time. So you said something interesting about credibility, right? Which I think of as how are you building trust with those developer teams, particularly when, as you mentioned earlier, you've got a wide range of diversity in culture, right? I think there's sort of two ways to think about it. One is technical diversity, right, which is in some ways built into the idea of DevOps, right? You give teams, individual teams, more responsibility. They're able to choose their tech stack, for example. So you're not saying everybody writes in C++. If you want to use JavaScript or Python, you can use that as long as you're containerizing your services in an expected way and you're working with the platform team to do that. So in some ways, DevOps can solve for that piece of the problem. But what to me is more interesting is the cultural diversity piece, right? You mentioned you have teams that are still building software in a data center using a lot of those old methods. And at the same time, you've grown by acquisition. So you've got modern, mature, very DevOps-oriented teams. But your job is to communicate with all of them. So you mentioned the kind of lingua franca of security that you're using to build trust. Can you talk a little bit more about that? How do you communicate to such a broad range of cultural diversity across multiple teams in the organization?
Yeah, sure. And it's an interesting story about when the founder bought the company, the then CTO, they was acquired, small company, bought it for $1,000, I think is the story.
Wow.
And he's like, the CTO went to the founder and said, if we need to develop this like flagship product in Java, otherwise all the devs are going to leave. It has to be Java. And he's like, okay, fine, do it. So our kind of foundations is Java, but then as we acquired these very large companies, you have to be really careful. I mean, let's put it this way: it's impossible to say, like you said, now thou shalt do this, because the big teams, big applications, the 2,000 developers, you've got to keep the train rolling down the tracks. See, and they're doing a good job, right? And the app's good and works and is making money. So no, you don't want to disrupt that. So I think we struck a pretty good balance in terms of like structure. Our CTO has 3 sub-CTOs for each of the segments, our main market segments, and they kind of run their own show kind of independently from a tech perspective. But then because he's over everything from a governance perspective, they kind of roll up. There's a singular SDLC. We have more or less a shared service model when it comes to engineering functions. So it's like a delivery model for you need a repo, SDLC type components, Coin, Jenkins type build infrastructure. They kind of take orders in terms of, what do you need, and then they kind of oversee and manage that. So that gives it somewhat of a singular interface. And then on the security side, like I talked about with the IPTs, that is governed So it has teeth. So if you miss SLAs for critical and high findings, and you push the date back a second time, that then is kind of, there's questions asked at the top levels.
Yeah.
So it's meaningful, and people know they're gonna, someone with a C in their title is going to ask them, what's going on with this? It's a high, you haven't fixed it, we've blown past the date. So that's real, so we don't just pay lip service to that. So it really helps me get things done.
Well, and what it sounds like you're doing is using both the carrot and the stick, right? You've definitely made clear that you need respect for those SLAs, but at the same time, you're investing in a platform team that is supporting the developer experience, right, within the organization. And that's a term that gets thrown around a lot, right? I think if you've never worked with software, it's easy to have this conception that developers just sort of like sit at their chair all day and are typing, lines of code for 8 hours straight. But it's actually a much more sort of disconnected process of iterative problem solving. You're spending most of your time reading and attempting to understand and figuring out why there's an error message and doing additional research to figure that out. And then ideally, you come up with a solution, change a line of code, and then in the best case scenario, you get a new error message, right? And you start the process over. So I don't think there's a ton of understanding, at least until recently, about what makes a good developer experience. But at least from what I've seen in recent research, it seems to boil down to three things that certainly make sense to me as I think about my career. One of them being flow state, right? So keeping developers concentrating on the problem in front of them, right? We all say, well, developers don't like going to meetings, and that's true. The reason why that's true is the act of context switching for a software engineer is very expensive, right? You have to go, answer the phone or go to your meeting or respond to an email, and then you come back and you have to reestablish all of the context that you had in your brain about which files are related to which classes and how does the data flow in my application. What problem was I even trying to solve? What was the error? How far did I get? What did I try and not try? So by the time you've reestablished all of that context, you've lost a significant amount of time, thus making you less productive. We all have memes about the pointy-headed boss who doesn't seem to understand that, right? Yeah. The second one is generally called cognitive load, the idea that if you're forcing a developer to establish additional context outside of what they already understand, that's also an expensive operation. They have to open up a new browser tab. They have to get feedback from someone else. They have to do additional research, which again is slowing them down because they can't make another iteration, right? They can't attempt to solve that problem. And then the third piece, which is related to the cognitive load, is the length of the feedback loop, right? So the length of time it takes them to get that response from whoever that third party is. And what I find so interesting about this new sense of developer experience or productivity is traditional application security gets all of that wrong, right? It basically says we're pulling developers out of their flow state because we're making them focus on the vulnerability that security says is important, not what's in front of them at the time. We are increasing their cognitive load because they then have to go out and do research on, like you were saying earlier, is there a firewall rule that's protecting against this? What's happening on the edge? What's the business criticality of the application that I'm working on and everything that it inherits from? And then finally, the feedback loops are extraordinarily long because the security context is owned by, often, the AppSec bottleneck, not fully integrated into the developer tool. So I have to say, is this really a critical? Is this really a risk? And then I wait, right? Because often it's one security professional or one AppSec engineer to 100 or 200 or 500 developers. So they're waiting in line. They're losing productivity as a result. Does that story kind of ring true for you in terms of your developer experience? And how do you think about both the constructing their experience of security, and then also how do you message that to show that you're really on their side? Your job is to increase trust rather than that traditional kind of erosion of trust we often see between developers and security.
Yeah, I think we really, the reason we moved to Snyk in the first place was to really make their lives easier. Mm-hmm. And I say that because the current tooling of the day, and this is where Snyk really innovated, was right at the very end, that's when you fix all your stuff. That's where all the findings, that's the security tool, it brings all the findings up right at the end. And then there's two tools. There's open source and there's SCA, and so they're locking in two different products right after they probably coded that thing weeks or months ago at that point.
Right.
And then separately, there's just so many findings and no context. So you end up with a huge backlog. So I'm in the role at this point 3 years, I think, around, and soon after we bought Snyk. But that was the main problem as I saw it when I took over the AppSec global role, and the idea was twofold: to just bring it much closer to them as they're working, and also to have a singular interface. They're in one tool, working in one tool. They don't have to switch between multiple different products. And then separately, just building this IPT workflow, normalizing the findings from Snyk. So.
Yeah, and you mentioned something interesting as well. They're looking at both their static analysis findings and the composition analysis side by side. But then there's other concerns as well. There's container security, right? There's infrastructure as code. And all of those can introduce risk on their own, but they can also combine in interesting ways. You think about a number of recent vulnerabilities, but to choose one I think most folks are familiar with. If you look at Log4Shell from a couple of years ago, what is required in order to be exploited by that vulnerability, or what actually enables it to translate from an issue into a risk in your environment? Well, the easy answer is to say you need Log4j 2.10 or 2.11, whatever the vulnerable version is. And that's true, but that is necessary but not sufficient, right, to exploit it. You also need that vulnerability to be, or the vulnerable package to be installed on a container with a particular operating system. You need that container to be deployed to an environment that has inbound internet access. You need egress traffic on an LDAP port, right? And you need there to be some kind of business importance to that asset, right? Because if you're deploying somewhere, even if all those technical factors are true, but it doesn't actually affect the running of your business, is it a risk, right? Or is it certainly not the same kind of risk than it would be if that's going into one of your kind of crown jewel assets? So when we think about context, we think about needing to collect these factors from multiple layers of this modern cloud native stack, right? And that's to say nothing, by the way, about all of the third-party APIs, the cloud services themselves, how those interact with each other. So the idea is that risk in modern software is really multifactorial, right? And I think you said something interesting earlier, which is that in the developer workflow, they can't see any of that until the very end, right? But the traditional response of, well, just stop and test it after is contrary to the entire philosophy of DevOps and Agile development, which is you should always be iterating, right? You should always be in another cycle. So I think it's interesting that we're arriving at this place where we're realizing we need to reinvent security in terms of developer experience. I guess, though, so is that, when it comes to building trust with your teams, right, is that something that resonates with them? And do you find that developers are understanding of the position that you're in trying to inject all that information into their workflows? Or are there still kind of gaps and challenges that you're running into?
Yeah, I mean, there's certainly gaps. And we're obviously trying to evolve. Currently, where we're at, I mean, it's always a balance. Like you from compliance perspective, we have these certain things that need to get hit, depending on the criticality of the app. So they'll work through those things. Implementing DAST, is DAST implemented? Is SAST implemented? Is SCA implemented for any given application? Just for context here. We have a dashboard, and each application has an assigned lead, an application security lead, and an assigned owner. So there's a one-to-one match between security and the owner of an application. So, and to your point earlier, yeah, you have a lot more devs than there are security folks. So really, it's a real partnership in that they got to do most of the work to fix that stuff. So we have the compliance view, and then there's everything else, right? Quantifying that. It's really where the journey, the journey we're on. We want to kind of bring all these different elements into play. Things that aren't traditionally, I would say, catered for right now. So, for example, do you have a WAF in place, and is it blocking for an application? If you go and try and actually test it out in your particular case, it's actually kind of hard. It's kind of hard to figure out. So we have a program internally that we built out. It's actually part of the red team. It's called A8N, which is short for automation. Actually inspired by an Amazon department when they were doing the typesetting, and apparently there's two competing teams, and there's this automation team that all just automatically typeset the front page of Amazon.com. So I got inspiration from an Amazon book I read about that, but the whole idea is you can instrument a lot of different tests in the workflow, and all the way down to, what is your policy with respect to, say, code review, and where is it implemented in the repos?
Right.
So it's a multifaceted problem that parse the policy, codify it somehow, and then check to see if it's in place. So all these kind of elements kind of feed into.
Well, and I can't help but think that the common element in everything you're talking about is that's a lot of engineering time, right? That you're asking for, and as I think an AppSec team anywhere, you're in an awkward position, right? Because you are accountable for the security of the services being produced by the developer teams, but you don't necessarily own the budget, right? That budget is owned by typically a product owner who reports to the business, who has an incentive to continue pumping features into production, right? All of their metrics are how quickly are we getting useful business value into production, not how secure is that code, right? Something happens, any sort of breach or incident, right? Ultimately, someone like you gets blamed, and maybe the engineer implemented it, but typically not the product owner of the service, right? Because they're the ones who are blamed when things slow down. So it creates this natural tension in which you're saying, hey, we've got all these critical vulnerabilities. We know they translate to real risks because we're collecting all of this context, because we understand what's happening at the edge, and we're integrating all of it together. But then you still have a final hurdle of you actually need to make the case for engineering time to get all these issues fixed, to say nothing of the kinds of improvements that you're talking about integrating into the workflows. How does that kind of conversation work? Or how do you kind of handle long-term technical debt management in that organization, understanding that you're going to need access to some amount of that time in order to make improvements, right?
Yeah, I hate to say that we solved it, but I feel like we've made it we're real close to like a panacea almost. And the reason I say that is because of the IPT process that I was referring to earlier. It really is, it functions in such a way that, one, all the vulnerabilities aren't turned into IPTs, so you have much fewer findings. Two, ultimately a platform owner who's high up in the business has to take ownership of those at some point. And that'll be part of a metric too, right? Yeah, you got to operationally, you got to keep the product up, you got to build functions, you got to make money, but at the same time, also don't have any critical IPTs. Or at least if you have them, fix them within the SLAs. So, I would say we're relatively unique. I don't want to say other people aren't doing this, but the process is meaningful, and because of the governance around it, we got to a point where it kind of works.
It certainly sounds like you've been able to align those incentives more meaningfully than they can be in a lot of organizations. Well, then I guess my other question related to that is kind of what's the role of security vendors in that process, right? Because there's certainly no tool that can solve a cultural issue in an organization. But as you're working through things like this IPT process, how you're communicating internally about vulnerabilities, that lingua franca that you mentioned that you're trying to align all your teams on, at the same time, you're managing, I would have to imagine, a couple dozen different security vendors that all speak a little bit differently about those same things. Yep. So how do you handle those relationships? And I guess what do you look for in a relationship with a security vendor that says, okay, we can work with this tool because it is able to understand where we're trying to get to culturally and the communication style and how we're assigning vocabulary to a lot of these different concepts internally?
Yeah, from a pure technical perspective, they've got to have an API. So we've automated everything. So we need to be able to call, pull back the data, and then, extract,
make it speak
load.
your language.
Yeah. And then really it's a manual process of reviewing the vulnerability source data and turning it into something that is relevant from an IPT perspective. So the IPT, the issue problem threat calculus is, on the face of it, is standard risk calculus, like likelihood times impact.
Well,
right?
Yeah.
But then on top of that, depending on the tool, some tools have exploitability data, other tools reachability data. So we pull that in and then we review the output and understand, well, and we've messed up in the past. We've assigned hundreds of IPTs and got feedback because we didn't do a good enough review process. And the devs say, yeah, this isn't relevant. And they're like, yeah, sorry, we screwed up. You got to back it out. But that's a bad spot to be in.
But you're at least reestablishing that trust relationship with them and understanding, hey, here's why this happened. Here's how we can correct the process in the future.
Yeah.
Well, I do have to point out that you kind of said a dirty word earlier when you were talking about manual processes at an AWS conference. So I think that segues kind of into what I wanted to talk about next, which is as we think about this next phase of DevSecOps evolution, we're at this point now, 10, 11, 12 years in. Everyone kind of roughly agrees that automation is a good thing, but clearly there are gaps, right? As you mentioned, you're having to do a bunch of work because the outputs from various security tools don't correlate with each other.
Yep.
You have to manually stick those into your lingua franca. You are having to still define internally what a sense of an issue is because you can't rely on any kind of commonality in the data that's coming out. In addition to all the other inefficiencies we've been talking through, right? That constant trust building you're having to do, even though, as you say, you're pretty close to a panacea in terms of your ability to get the budget you need, the leadership structures and everything that enable your organization to move, even understanding the huge amount of kind of technical and cultural diversity you're dealing with. So I guess I would ask kind of two questions here, looking forward in terms of ICE, kind of what's next over the next couple of years in terms of furthering to refine that process? And then also, just when you look at the industry more broadly, what are you excited about in terms of innovation in that DevSecOps space sort of moving forward over the next couple of years?
Yeah, and they're really correlated. But first and foremost, what we're doing, and I hate to use the phrase security champions because it is, it means different things to different people. But right. I've been loath to implement what I understand to be a traditional security champions program because I'm kind of under the impression it's the folks who put their hand up first, but may not necessarily be the person you want.
Right.
Champion the program, and is their stuff good? I mean,
there's certainly a person
they fix
who
all
wants
this stuff.
Yeah. So
I'm like, I'll do it. We may not call it security champions, and really, the process that I talked about earlier with the AppSec leads, and like we've been championing security for years at this point. But I want data-driven perspective on an application, like a holistic view, like call it a credit score, what have you, and app risk is a good example of that, right? A consolidation of various factors that go into the security application, not just the code, but also SDLC components and other controls, and then you end up really with a kind of a holistic score. And you can take that. This is more of an abstraction because we live in IPTs today, where we want to move towards, and it's fine-grained, so it's like so many of those IPTs, but then like, well, which app is more secure than another app? And the dream state for me is kind of matching those folks with good scores to people with maybe not so good scores, and maybe they work in the same architectures, and then, hey, can you all work together and like share some best practices here to get the score up? Really is kind of where we're headed.
Yeah, and gamifying it, right?
Yeah, gamifying,
There's
that's
an
right.
incentive there for developers to understand the implications, and obviously, using the carrot more so than the stick. Because what I think, again, you think through my experience as a developer, there's a certain it's not that you don't care about security when you're writing code. It's that precisely because you don't understand those risk implications until after the fact, there's a little bit of maybe I'll call it a bitterness there, that like, boy, I wish you could have told me this when I was making that decision the first time instead of after the fact. But as we've been pointing out, there are some key kind of unsolved problems still in the AppSec space, the DevSecOps space, that are preventing us from getting there. One of them is cultural, as we mentioned. The idea of, I don't know if you know the analogy of chickens and pigs, right? If you think about a breakfast.
I do now. If you have to explain it to me outside.
I did. All right. So, but you think about making breakfast, the chicken's involved, but the pig is committed, right? And what we see, I think, in a lot of organizations is the alignments of responsibility and accountability for security are not necessarily drawn where they need to be to ensure that everyone's properly incentivized. As we mentioned earlier, which it sounds like it's a problem that you're close to solving, how do you assign the right incentives to the product and business owners to care more about security by default, as opposed to creating friction by pushing back and saying, no, we really need this release to go through. Yep. And then there's some technical kind of gaps as well. Which I think you were getting at a little bit with the idea of a cohesive risk score. You said earlier using SAST and DAST. Most organizations do, right? The reason you have to use SAST and DAST is the tools work fundamentally differently, and they each have different strengths and weaknesses, right? SAST runs by looking at code, making assumptions about what vulnerabilities might be in there, and then making recommendations, because you can point to exact lines of code and say, you need to make this change. It can be closer to a developer. The trade-off, though, is that it's not terribly accurate, or at least is not perfectly accurate, because it's only looking at the application from the inside. It's what we call a white box test, right? On the other hand, you have DAST, which looks at the application from the outside. It's a black box. It's attempting to exploit and then reporting on those results. So highly accurate, because you can say, did I exploit this or not? But you lose that connection to the developer. You can't explain anything. You can't recommend remediation. So in a lot of ways, the holy grail of AppSec or DevSecOps would be the idea of correlating those results, being able to say we've traced back this idea of a black box test, and we've found the corresponding issue on the white box or the static side. So we can now say to a developer, yes, we know this is accurate, and we know what your remediation step is. So when I think about kind of where the gaps are and maybe where we want to head in the world, I think, boy, we're here at AWS reInvent in 2024. Most, if not all of us, are doing some form of packaging as code, with containers. We're doing infrastructure as code with CloudFormation and so forth. Very few people are doing security as code, right? Precisely because of these problems that we've mentioned, where you can't actually understand what the risk import is of a piece of software until after it's already built, which is the wrong time to tell a developer what to do about it. So I see a world potentially, as you're mentioning, if all of this context is collected, and we now have strong enough machine learning models that can, I got the bingo card, right? We mentioned AI. We now have strong enough models that understand code, that understand software, that could potentially work to correlate all this together to then finally make security into something that can be declarative from a developer perspective, the same way they can now declare infrastructure and packaging and everything else. Is that just a pipe dream, or do you actually think we're moving toward a world in which we have now a threat model that can be derived from a combination of all those factors attested to? So a developer simply has to say, this is how I want my application to be tested. These are the threats that I think exist. And then all of that simply runs in the back end now, the same way we do for cloud resources, containers, and all these other pieces that are now declarative as code by a developer.
Yeah, I think now the technology is now there.
Yeah.
Right. So the data that we can churn through, pause, and ultimately, programmatically enforce controls at the code level, I think makes a lot of sense. I think that's coming.
Are there other potential use cases you see maybe for AI or ML kind of in that world, or where is there potentially a gap if somebody out in the audience today says, boy, I'm really looking for a startup idea to make a lot of money in DevSecOps, like what's that one piece that Craig Lambert at ICE would say, this is the tool I really need to go out and buy that doesn't exist on the market?
Oh man, you're putting me on the spot here.
I didn't prep you for this one.
Yeah, no prep. So an AI tool that
it doesn't necessarily have to be AI, but what's kind of if you got your crystal ball and say in 2 years I would really love this one AppSec capability that I don't have today, kind of what would it be?
I would say I mean, I don't want to get too far ahead of myself. There's stuff today that needs to get fixed.
Yes.
Right. So I think I think the problem is when there's a lot of new products in the market that that you kind of get distracted by there's still some real issues that still need to get solved today. I think a good example of that is the consolidation of vulnerability findings.
Yep.
And we've seen quite a few products come onto the market of late to kind of solve for that, which is the IPT process. Not to keep going on about that, but it's literally a filter for a manageable number of findings. But again, the contextualization, I think a lot of those products still, even today, can't contextualize. And I think the reason for that is because they develop products in isolation from any given business. So, you almost have to think of it in terms of how can you abstract away some business intelligence enough to make it generic and turn it into to solve for that, right?
Yeah.
Language, and then some of the tools out there that try and do that with inventory, and that's probably the way to go. But you have to get pretty good at doing inventory, and then what do you include in there? I think some of the scope for Gen AI is the fact that you can pull out a lot of internal data in a contextualized fashion in a way we haven't really been able to do before.
That's a really interesting idea, right? So a security platform that gets the primitives and the component layer right flexibly enough that then a Gen AI tool could potentially create workflows on top of it that correspond with how you're doing things internally, right? And ideally, that tool would end up building what you've done so much manual work in for your organization, but also for others, not only in financial services but other verticals, other layer, different landscapes in terms of technical and cultural diversity, like we mentioned.
Yep.
So I guess that's our big startup idea, right? Is how do we find a security tool that corresponds with existing workflows without being too opinionated, being flexible enough, but not requiring someone like you in your position to say, we have to build an entire manual process on top of these tools because nothing talks to each other. There's a lack of open standards because vendors don't have an incentive to share what they're doing. And instead you have to buy 25 different tools and then do the painstaking work of stitching all that together.
Yeah.
Well, I guess we'll come back in a year and see if that has come true.
Yeah, if someone wants to send us some money to get that going. we'll take it.
Hopefully that'll be the next big DevSecOps innovation we're talking about in 2025. All right. All right, we'll give you a few minutes back. Thanks to you, to Craig for the conversation, and thanks to everybody for coming out today for another reInvent. Appreciate it.
Thanks so much. Appreciate it.